Part C of question number 5 says, for the interval 0 to pi and for y greater than 0, find the coordinates of the point where the tangent line to the curve is horizontal. Okay, so we want to find where the derivative is equal to 0. So I've set the derivative equal to 0, and the derivative expression is y cos x over 4y minus sine x. Okay, so this is what was given in the first part. And if this is equal to 0, I can just solve for the numerator equal to 0. I just have to make sure I have a restriction that the 4y is not equal to sine x. Okay, so we don't want the denominator to equal to 0. However, that's unlikely, so we can just go ahead and simplify this equation to solve this as 0 equals y cosine x. And we can solve these since it's equal to 0 and it's factored, we can solve these independently. So we can solve this independently for y equals to 0. However, it says that since y is greater than 0, we can disregard this solution. So we can disregard. Okay, since y is greater than 0. For this part of the equation, though, we can then solve this as cos x equal to 0. And if we take a look at our circle, the cosine is a horizontal positioning. It's equal to 0 up here and here. So we end up with our value of cosine equal to 0 at pi over 2 and negative pi over 2. Okay, and again, since we have the restriction from 0 to pi, we can then say, so x is equal to negative pi over 2 and pi over 2, but because of this restriction that we were given at the very beginning, okay, because of that restriction, we're just going to say that we're going to eliminate that solution. Okay, so that solution is one that we don't need to consider. So once we have x, we found x, we need to find the position, so we need to find, so it says find the coordinate point of the point where the line is tangent. So we have the x position, we just now have to find the y. To find y, we're going to plug this into the original equation. So our original function was this. Our original relationship was 2y squared minus 6 equals y sine x. Okay, so I'm just going to plug that into there. And then I'm going to solve that. So I end up with 2y squared minus 6 is equal to y times sine of pi over 2. Sine of pi over 2 is equal to 1. So my equation then becomes 2y squared minus 6 equals y times sine of pi over 2 is equal to 1. Okay, so then I have my quadratic equation, y squared minus y minus 6 is equal to 0. So then I can factor this to solve. You can factor in all sorts of ways. I'm going to factor using this strategy where I take the first and last term and I multiply those together. So I get negative 12y squared, and then I use that product to split the middle term of negative y. So I get negative 4y, positive 3y. Okay, to split the middle, multiplies to negative 12, adds to negative 1. And then I can see that my side lengths of this rectangle is, I'm going to factor the 2y out of here. So this is 2y plus 3. And here I have y minus 2 along the horizontal. Okay, so my factored form, again, any way you want to factor this is going to be perfectly fine. We'll just make sure you have a strategy that is relatively concise. So I end up with y coordinates of y equals negative 3 over 2. And again, I can disregard this since y is greater than 0. This is extraneous since y is greater than 0. And then I need to only consider the coordinate y equals 2. So then the point of tangency, where the line tangent is horizontal, where we have 0 slope, the point is at x equals pi over 2, y equals 2, and that's the point that I'm looking for.